All right, welcome back to Live Demon Programming. In this video, we're going to set up a password hashing system so that we can protect passwords, and we're going to also validate the password, make sure that it's good and strong. I'll show you how we're going to use a crate that's available for doing that, for scoring a password. And then we're going to create a player account and get that all working, and we'll be almost ready to start storing that and creating a login system for our players on our server that we're going to build. So glad to have you here, and let's get going. All right, so where we left off last time, we completed this email validator, at least up to the validated stage. We don't have a verifier yet. We'll do that when we get parts of the server working. Now we want to do a thing with processing passwords, and I don't know how this got bumped out like this or in like this, but fix that real quick. Keep it neat. So what we're going to do now is password. So here we're going to do something very similar, except for this one I'm going to do this derive. Oops. Derive debug, because I want to be able to print out the password system here. Not struct. Enum. Okay, we're going to do something very similar with passwords, except we're going to have hashed of type string. We're going to have a U8, and we're going to add in here what's called crack times. And we're going to have invalid, which is going to have a string that's going to be a message, U8, and we're going to add in crack times to this as well, so that we can send a message saying, hey, it's invalid. I guess we need a name for it. We're going to call it password. So this is how we're going to handle a password. We're not going to pass around the raw string password is only going to exist long enough to produce this. When it produces a valid one, it'll be hashed. When it produces an invalid one, this will contain a message. This will contain a score, and this will contain how much time it takes to crack that password, so that we can advise the user on how to correct their password. So we want to implement this. Implement password. And again, we're going to do a pub fn new, and this is where we're going to pass in the actual password as a string, and we're going to return a password. And of course we can make this self. And so we're going to say this is where we're going to use this ZXCVBN package that we imported here, if you recall, in the cargo toml. This one right here, we're going to use this package, and we're going to use some functions on it up here where we imported it, the crack times and this ZXCVBN function. So let estimate equal, and this is where we're going to go ZXCVBN, and it needs to be ampersand password. We don't need any additional inputs for this, but we got to send in a reference to an array, and then we're just going to unwrap it. And unwrapping is, in some cases, dangerous, because it can cause the system to crash. But this is going to return us something we can use no matter what. Even a bad password, it should return something correct. So unwrap isn't unsafe with this. We can get more out of it if we pull back the actual result we can get back the error message, but we'll worry about that later. I want to keep this relatively simple. Well, yeah, let's just keep it simple for the moment. We'll refactor later and get rid of this unwrap and actually check the error. So what we're going to do now is ask if the estimate that we got back and the score on that estimate is greater than 2. Then what we're going to do is go password hashed. Now is where we need to take care of the password hashing. And to do that, we're going to use this thing called bcrypt, which I imported in the previous video. We're going to call hash on that. We're going to pass in the password. And we're just going to do an unwrap again. Later, we may do that a little differently. And then we're going to pass in the estimate dot score. And then we're going to pass in the estimate dot crack times. And that's what we will return from that. Else, we're going to return password invalid, and we're going to send a message. Your password is not strong. Please make it more complex. And then we're going to go ahead and pass in the estimate dot score and the estimate dot crack times. Okay, so what does all this mean? Why does it not like this? What is going on here? Let's do a cargo build. Let's see what went wrong, if anything. Well, for one thing, I need to turn this into a string from this. Bcrypt. Did I not import bcrypt? Well, I'm using it right here. What's wrong? It failed to resolve use of undeclared creator module bcrypt. What? That doesn't make any sense. It's right here. Did I not import it? Cargo toml. I guess I didn't. Oh yeah, pw hash. It's right there. There's pw hash. Oh, I spelled it wrong. That would be why. Okay. And there, it built. Okay, so what this new is going to do is either return a hashed password, or it's going to return an error message if it's invalid. So I want to test this, so we'll put some tests down here for it, but I want to test it using let's use the client main. So to use our module, we're going to have to create a dependency for it, and this is in the client cargo.toml. We need to have rust mud oops, hold on 1 second. Let me go check this. And yes, should have been rusty, mud, common is what we want to import, and we need to give it a path. So we're going to say path equals ... slant rusty mud common. So this is how we're going to reference within our workspace our individual any additional crates that we set up. We're going to reference them here as a dependency, and then in main we can call that out. We can say use rusty mud common :*. Actually, that's supposed to be : and actually I'm going to do this, and I'm going to go player star. Okay. So now let's make up a crazy password. Let pw equal, and we'll put a bunch of characters in it and some symbols and numbers. And then we will go let pass equal, and it's going to be password : new, and we're going to pass in the pw. Okay, and now for the moment we're just going to print it out. And we will run this cargo run -- bin rusty mud client. Hopefully it'll build cargo pw expected a string. Oh, that's because this is we'll do 2-string. And I will expand this a little bit so we can see. And here it is. It ran. There is our hashed password, which we can use and store reasonably safely. It has a score of 4, and this is how many guesses the crack time. This is how many guesses it would take a hacker to guess the password from the hash. So let's make a bad password like Bill and run that and see what kind of score we get. Okay, and it's only going to take 155 guesses for them to come up with Bill, and it's got a score of 0. So if we made it something like my longer password as a phrase, and see, that's a good one too. So it came up with a score of 4. It actually hashed it. It didn't give an error. Your password is not strong. Please make it more complex. So the point here is that using this kind of an algorithm to test the password doesn't restrict the users to having to use special symbols or a particular length. If they can come up with a reasonably strong password, even a passphrase like my dog loves meat pies. And see, that's a fairly strong password as well. So our passwording system is working reasonably well. Now we can come up with some tests for it, which we'll do later. I'm going to move on. We've already kind of gone over testing. I'll do the tests later and post them up there. You can take a look at them yourself. I want to move on with getting some other stuff done here. Let me go. Oops, wrong one. Okay, so that takes care of the password part. Now what we want is our Am I in the wrong branch? Of course I'm in the wrong branch. There we go. So now we've got both an email and a password, and we can go ahead and create our player structure. So now I'm going to talk about structured data. So pub, struct, and we're going to call this a player account. And we're going to keep this player account very simple for the moment. We might expand on it, but basically you name the fields and then a colon, and the type like is fairly standard in everything we've been doing. So we're going to have an ID, and we'll just make it let's make it an I-64. Why not? Bigger number. We might change that to UUID or something in the future, but they're going to have an email, and here's an email, and they'll need a password, and here's the password. That's the type. And then just like with the Enums, we can create an implementation for player account, and we create a public function new. And what we're going to need to pass into this new to create an account is going to be an email and a password. So instead of having to process it, let's just pass it in as a string. So here's the email. Well, we'll pass in an ID of I-64, which will have some account system that comes up with appropriate ID. Then we're going to pass in an email as a string, and we're going to pass in a password as a string. And then we're going to have it go through the verification at least the validation process to validate the email, validate the password, and if everything's good, it's going to create the account. Otherwise, it's going to come back and tell them an error. So what do we have to do that? So let's let email, email let's call it email address equal email new email. Let pass equal password new password. Now we can in fact match on multiple items. So let's do a match. And we're going to put this in what's called a tuple. That's a structure we haven't talked about before, but we're going to match with email address and password and pass. And what we expect to see coming back from that match is going to be a tuple that contains email : you know what, actually I should do up here, instead of new email, I should go process. Validated EM and password hashed. PW score and cracks. And then this, so that's our pattern. And what we're going to do from that pattern is put this down here and indent it. It's a little bit easier to read. If both of those come back that way, and we've got a hashed password and a validated email, we're going to return this structure that has ID, which is the ID we passed in, email, email address, and password of type pass. Comma. Anything else that is returned. I made a mistake here. So pub fn new, first of all, we're going to return, we're not just going to return this structure, we're going to return a result of type player account and error. We'll make it a string. So what a result object is, it's a result, it's an enumeration that contains either OK or error. And if it's OK, the OK block contains the player account in this case, and if it's an error, it contains a string. So on this one here, where we return self, we actually want to return OK and all of that. And then for this one, what we want to return is error, and then we unfortunately don't know precisely what the error was here, but we can say that you know what we could return? We could just return the result as, let's make it a tuple that contains email and password that came in. And so for the error, you know what, we want to make it a, got an extra thing here. We want to put a string in here too. Okay. So our error block is going to be invalid email or password, comma, and what we're going to pass in is email address and pass. But we've got to do it as a tuple. So we're passing all that in as a tuple. There it is. Let's see if this compiles. Cargo build. And again, this needs to be a 2.2 string. Pass, value used here after move. Okay. Let's just make it a string. And we'll just send the error message. Build this. Value used after move. I don't understand why I get tripped up sometimes over this borrowing stuff in here. Still haven't quite mastered it, but I can usually figure out how to work through it. So actually, instead of trying to do this stuff here, we're going to pass in an email and a password. And instead of doing this matching, let's just return it as an object. Let's just return the player account. Actually, we can also just do self here. And then we can go self. ID is going to be ID. Email is going to be email. And password is going to be password. And then we'll set up instead of trying to do it in there, what we're going to do is set up a little process for validating it. But let's go to our client now and check out the player account. Also, I'm going to add this debug here so that I can print it out. So what the derived debug does is it lets you just print this whole object out and see what it shows. So let's go over to the client, and we've got our password. Let's do an email. Let email equal someone at someplace.com dot to string. We'll go let email equal email new email. Oh, by the way, this is called shadowing, and we can actually make this one be PW. So it's called shadowing because it's actually redefining this. It's not setting this to a new value. There's now a new variable in scope called PW that is shadowing that PW. So we can change this to, we're going to now create a let account equal player account new. We'll just call it 1, and we'll go email and PW. And then that's what we'll print out is account. And so let's run that. Email. Oh, email. Oh, okay. So let's go back here to player, and everything you're going to use in one of these needs to have this, and I never put it on this one, so it should work now. There it is, running. Okay. So now we've constructed a player account. We've got an ID. We've got, in this case, a raw password. Oh, because I didn't call process. Let's go back to main. New password. We didn't want that. We wanted it to be process, not process email. And there it is. There's the validated email and our hashed password all automatically developed for us, and with the crack times and everything stored in that. So what we can do, what are we? Let me look at the time here. Yep, we're at 28 minutes. So that's going to be it for this video. I'll quickly review here. So we've created a password. There's the email password. Password enumeration, it's either hashed or invalid. We don't keep the actual password around for any length of time. As soon as we get it, we pump it through this and get either a hashed value or an error back. And something about the crack times and stuff, so we can advise the user about the strength of their password. And we'll come up with a little algorithm here to give us a bar of like 1 to 10 or something using these values. We can create a new password and it hashes it. and we can create a user account right here, a player account, excuse me, using this and using those pieces, and we'll come up with a function to process it in the next video to come up with the account and give back appropriate error messages. Perhaps in the next video or possibly the one after that. In the next video, I want to do serialization so that we can save a final user account or player account rather into a file so that they can log in, and also how to validate a password against a hash. And so we'll be going over all that in the next video. So that's it for this video. Thanks for watching. I hope you liked it. If you really liked it, hit that like button. And if you subscribe, that would be hugely appreciated. Subscriptions really help my channel out a lot, especially in placement on YouTube. So, and if you want to know when I post new videos, hit that notify button and set up your notifications. And that's it. Thanks for watching, and I'll see you in the next video. Bye now.